Hello, everybody. My name is Maxim Goryachy. I'm a security researcher at Positive Technologies. Unfortunately, my sole speaker couldn't be here today, and I'm talking alone. You may have heard about our previous research about Intel ME, such as high assurance program bit, which allows to disable ME, or about vulnerability which we found last year. And today I'm going to talk about vulnerability which we found in Apple MacBook laptops approximately 1 year ago. Really, I think this bug is a result, from one hand, growing complexity of chip design, and from other hand, security through obscurity principle. As a result, even gained manufacturers such as Apple not immune to configuration mistakes on Intel platforms. So, let me give you motivation and retrospective of our research. As we probably know, we found the bug which allows to execute unsigned code in Intel ME 11 version. It called Intel SA0086. And this vulnerability have a small restriction. For successful exploitation of the vulnerability, there is one disease condition. An attacker must have write access to ME region of SPI flash chip. It's hard for local attacker on a properly configured platform. And, of course, not in the case when attacker has physical access. And we didn't stop on it. We were looking for a solution for bypassing this restriction. And as a result, we found several undocumented commands which enable overwriting SPI flash memory and implementing the doomsday scenario, local exploitation of Intel ME vulnerability. At the root of this problem is an undocumented Intel ME mod called manufacturing mod. Actually, today I will touch a lot of many aspects of hardware implementation, modern Intel platforms. I will give you short information about Intel ME. After that, I will show you how you may using manufacturing mod for writing ME firmware. And we will look deeper on PCH for bypassing some other protection. Now I'm going to give some information about ME briefly and vulnerability which we found last year. What is Intel ME? How many people know what is it? Please hand up. Okay. Good. First, it's almost undocumented and very powerful at the same time. For example, it has full access to your platform's hardware, including CPU complex. It has capabilities to intercept all that you're doing on the PC. For example, because PCH, its main point in your modern computers, Intel computers, all devices links with it. For example, PCH devices, PCI devices, USB devices, and many other. And it's also a root of trust for many modern Intel security features like TPM, like DRAM, bootguard, and some others. Intel has chosen the following following design for ME11. Independent x86 core. Really, in PCH we found about maybe 5 microcontrollers. 3 it is x86 core, and 1 it is ARC core. And Intel's choosing Minix, such operation system for this firmware. ME gets started before main CPU, and its firmware has a parts in PCH built in into OTP memory, on-time programmable memory, and in the SPI flash. Now a little bit of formal description of the vulnerability. From the official security advisory for the vulnerability, it has high CVSS rating, and as now it has the local exploitation vectors. This vector will be the main point of my talk. Also, you can find on the slides affected platforms, all platforms affected: desktop, mobile, servers manufactured after 2015 years. And if you want to play with ME, on our GitHub you can find step-by-step instruction for exploitation this vulnerability on Gigabyte Bricks platform. Also, you can activate JTAG for ME core, and it gives you access to internal memory, to internal devices, into PCH. For example, I don't know. For example, access to internal buses such as IUSF, such as primary PCI, and many others. Okay. As I already said, an attacker must have right access to ME, access to ME region of SPI flash for successful exploitation of the vulnerability. But how can he get it? We saw several ways. In the first, incorrect flash descriptor settings, UEFI BIOS, also UEFI BIOS implementation. There are problems in settings of many regions in the SPI flash descriptor and processing of the UEFI setup variable in BIOSes. Also, having physical access to the SPI flash, attacker or platform jumpers makes all this system vulnerable, because he can downgrade ME version without any problem. So we met many systems working in so-called Intel ME manufacturing mode. This mode also can help to attacker. So let's explain how attacker do it. I need to give information about SPI implementation in the modern systems. So SPI flash is just memory chip in your motherboard. Flash memory chip, yeah. SPI memory divided into several regions, and Intel ME was located in separate SPI regions that had independent access rights for the CPU, descriptor region, and GBA. So, as long access attributes were correctly configured, it was impossible to read or write ME from the CPU side. However, current SPI controllers for Intel chipsets have a special mechanism called master grant. This mechanism assigns a strictly defined portion of SPI flash to each SPI master. A master controller is particular region regardless of the access rights indicated in SPI descriptor. Each masters can provide access for its region to any other masters it wishes. It's on the table. For example, BIOS can read descriptor region. Also, it can read or write BIOS region and couldn't have any read-write attempts to ME or GB region, for example. And also ME can read BIOS region, descriptor region, and write to ME region. But sometimes, for some vendors, this table looks like that. All masters can read or write everything. We tested some kind of platforms and received following results. On all gigabyte platforms, SPI descriptor isn't configured. Interesting that Apple gives read access to EMU region, and we didn't find any security issue in this fact, because all ME security sensitive data or signed or encrypted, and if you can read this region, you couldn't encrypt the data in, for example, SPI on MFS partition of ME, file system of ME. Also, how I already said, attacker can rewrite any region using special jumper which chooses hardware PCH strap. Some manufacturers gives access to this strap via DockStation socket. And this is the most interesting, that also a platform is required to have special settings in BIOS somewhere called flash rewrite enable. Having this, an attacker can write exploit into the ME region, but how does it work? We found that BIOS sends special message via H interface. And a few words about H interface. It's interface designed for local communication between CPU and management engine. HCI is a transport for many service protocols used by various modules inside ME. HCI is PCH device built in PCH, and just it looks like a ring buffer device. You have 2 pointer, and ME push data in this ring buffer, and CPU read from another side, and CPU also push data in ring buffer, and ME get it. Also, Intel implements a special HITB commands that allows opening write access to ME SPI region on the CPU side. The command called HMR-FPO, host ME region flash protection override. After receiving the HMR-FPO command, Intel ME opens access to the region only after reset. And Intel ME itself also includes security measures. The command is accepted only then the UEFI BIOS is owners of the platform boot process. Prior of different HCI command called end of post. It sends the UEFI to ME before exit boot services. And as a result, you couldn't send HMR FPO command from operation system by default. ME drop it. And on the slide, you can see as HMR FPO handling procedure. After power on, ME loading kernel. After that, ME starting a special module called BAP. The starting CPU. CPU is initializing memory. And after that, CPU sent another command, another HCI command called dit, the RAM init done. ME watching this command and BIOS loading the XE drivers and initializing another hardware. And on the last step, BIOS sent end of post message to ME, and after receiving this command, ME locking internal configuration. After that steps, you couldn't send, for example, HMR FPO or dit command. And really, but really procedure looks like this. ME checking on this step that manufacturer mode is active, and he drop end of post message and doesn't lock configuration. And after that, you can send message in any time, HMR FPO or dit, for example. Therefore, the manufacturing mode, in manufacturing mode, Intel ME accepts HMR FPO at any time. As a result, if the manufacturing mode has failed to close manufacturing, an attacker can alter Intel ME at any time. Of course, you need admin rights, but even the OS kernel internally cannot rewrite Intel ME, for example. At this stage, the attacker can refresh the ME region, such as to exploit vulnerability or to do break with your platform. Because now ME is bring up your platform on the power on stage. So a few words about manufacturing mode. Really, Intel ME manufacturing mode is intended for configuration and testing of the end platform during manufacturing, and as such should be disabled or closed before sale and shipments to user. However, this mode and its potential risks are not described anywhere in Intel's public documentation. Ordinary users don't have any able to disable this mode since the relevant utility is not called this utility called Intel ME system tools, and this utility is not officially available. As a result, ordinary users couldn't switch off this mode manually. As a result, there is no software that can protect or even notify the user if this mode is enabled for whatever reasons. This mode allows configuring critical platform settings stored in fuses. It's also on-time programmable memory. These settings include bootguard configuration. Looks like mode, policy, hash, and digital signature key for ACA module and ICH firmware. Many important settings you can skip if manufacturing mode is activated. Also, I show how it works. We saw that if manufacturing mode activated, and on the one hand, and from on other hand, what's happened when we send HMRFPO command in this mode. So on the start, ME WAP module into ME reading file HMRFPO from file system. And if this file contained 0, ME just reading HCI message, and if he received end of post, he logged configuration or waiting HMRFPO. If HMRFPO received, ME set non-zero value at file on the file system, and after that, on the next reset of the platform of the ME, ME get access to region because it set read-write access in SPI controller. We analyzed several platforms from a number of manufacturing, and we found that Apple laptops on the Intel chipsets are running in manufacturing mode. It means that on all Apple platforms you can, on all modern Intel platforms you can exploit it, our vulnerability without any problem and with local privileges. But Apple computers contains an additional check in the UEFI which runs even the UEFI is launched, and this check blocks startup of the system if the ME region has been opened with HMRFPO. However, as we'll show here, this mechanism can be easily bypassed. But challenge accepted, we need to look deeper in the on the platform. A few words about platform reset. Today, computers can be restarted in several different ways. The documented version includes a global reset and reset of main CPU only, without resetting ME. It's a piece of public Intel documentation which managed public reset functionality via special port, and it looks like that. You have global reset when ME and CPU are starting, and we have soft reset when only CPU are starting, not ME. But the ordinary question, is ME reset without CPU? If answered yes, it means that we can reboot ME, and ME opened the access to SPI region without, and in this time we are working in operation system. It means that we loading operation system, sending some comments, and after that ME description is opened. Okay, so when we explored the internal ME models, we discovered another HCI command for a reset only ME. Full description of this command you can find there. It's if I correctly, 3 means ME reset, 1 means global reset, and 2 means on last the word, and 2 means soft reset. Additionally, this command can be sent at any time, even after end of post. So, therefore, an attacker sends these 2 commands, HCI commands, and opens the ME region. After that, he can write arbitrary data there without having to reset the platform as a whole. And it doesn't even matter that SPI descriptor contains correctly set protection attributes. This will not protect ME from modification if the system is running in manufacturing mode. As a result, challenge done. It means what? You need to do 3 easy steps. On first steps, you send a message HMR of power. ME set internal file system the special flags. After that, attackers on the second step, attackers send ME reset command, and ME found these flags and give access to ME region. Of course, you need access to HCI device and SPI device, but it is based rules for all firmware attacks. So, small demo. Okay, it is MacBook Pro, and you can see that manufacturing mode on this laptop is enabled, the second lines, and we see that access to ME on write is disabled. You couldn't rewrite ME image as a result. And we are getting base address for HCI device. And we are sending the first command. I forgot. We're doing inter via EFI shell because we don't want to write a driver for macOS, because it is not as we think, it is not show you how you can send these commands into ME, and we did it via EFI shell. Okay, so after that we send the first command. We send a command which means the OK ME command ready. We get status from ME answer. ME read the value, the command, and we are sending the second command. On this step, ME after that opening will open ME region. We send second command. We send command ready, and now we are dumping ME region and rewrite it on new value without any problem. Oh, okay. Sorry. One moment. Okay, after this information was reported at Apple, the vulnerability was patched in macOS and High Sierra in this update, and also we exploiting this vulnerability. By exploiting this vulnerability, an attacker could write old version of Intel ME to memory without needing an SPI programmer or access to jumper, in other words, without any physical access to the computer. Thus, a local vector is possible for exploitation of Intel SA0086, which enables running arbitrary code into ME. So, to keep users safe, we decided to describe how to check the status of manufacturing mode and how to disable it. The first, it's Intel's utility ME-info, which we already saw. Actually, users doesn't have access to this utility. It's only for manufacturer. But we also created a program, a simple script on the Python for checking the status of manufacturing mode. On slide you can see output of the script on vulnerable system, and also links at GitHub where you can download it and checking your computer. In the famous firmware util chipsec also had been added a test on the manufacturing mode several days ago, maybe 5 days, maybe 7, I don't remember. So on the logical question is how user can close manufacturing mode themselves if the manufacturer has failed to do so, for example, on gigabyte platforms. To disable manufacturing modes, you can use FTP FPT. FPT has a special options, close manef, that is additional to its main purpose, also allows setting the recommended access rights for SPI flash region in the descriptor. And you can see the result, the output of this utility on the screen. Okay, in summary, the ability to reset ME without resetting the main CPU may lead to yet additional security issues, because it is not all firmware understand that ME can reset without main CPU. And also we show how you can exploit it, how you can bypass restriction, which we found in another vulnerability. We found one vulnerability, after that we found the second vulnerability for bypass restriction for the first vulnerability. And this is it, I think. If you have any questions, also you can find the full paper of this research on our blog, and also you can get utility and proof of concept of our exploit on our GitHub. Thank you very much for your attention.